This is your lecture for 6.5. In this lecture, we're taking everything we've learned in sections 1, 2, 3, and 4 and throwing them into one section. So instead of telling you what formulas to use to factor, you have to look at it and determine what to use. Okay, the first thing you always look for is a common factor. Well, I can see a 2 is divisible into all those. And there's no variable in common, so just a 2. Dividing by 2, I have x squared. Divide 4 by 2, I've got 2x. And divide 48 by 2, I've got 24. Okay? Because the x squared has an understood 1, I go over here and I say, what are the factors of 24 whose difference, because this is a minus, equals -2. We'll deal with 2, and then we'll make it a negative in a minute. Well, 1 times 24 doesn't subtract to give me 2. 2 times 12, no. 3 times 8, no. 4 times 6, hey, that'll subtract and give me 2. But since I want a -2, my bigger number has to be negative. And since it's a 1, I can go directly to my 2 parentheses. X and X, and here I have a +4 and a -6. Okay. Again, what's in common? Well, I can see a 2 because they're both even. Start with what you see. Divide by 2 and divide by 2. Okay, so 8 and 27, nothing in common there. And it's 2 terms, so it's either going to be perfect cubes or perfect squares. Well, because this is m cubed, we know it's going to be perfect cubes. So if you remember your formula, first, what do you cube to get 8? If you don't know, go to your calculator and do the cube root of 8 and you get 2. What do you cube to get m cubed? You cube m. What do you cube to get 27? You cube 3. So the first plus the second, the first squared minus the first times the second plus the second squared. And the last step, all you have to do is kind of simplify this second polynomial parentheses. So when I square 2m, that's 2m times 2m, which gives us 4m squared. -2m times 3 gives us a -6m, and 3 squared gives us a 9. Okay? All right. Well, let's see. What do we see in common here? Well, they end in 5 and 0, so that tells me there's a 5 in common. I don't like a negative first term, so I'm going to factor out a negative. And then I can see they both have an x. So divide by -5, the -5 is gone. Take away an x, you have x to the 4th. Divide by -5, you have -16. Take away an x, and you're done. So is x to the 4th a perfect square or a perfect cube? Well, 4 is divisible by 2, so it's a perfect square. So what do we square to get x to the 4th? Remember, we divide the 4 in half and get 2. What do we square to get 16? Again, if you're not sure, go to your calculator and do the square root. We still have our negative 5x, and according to the difference of squares formula, the first plus the second, the first minus the second. Now, before you consider this done, if you look, you notice these parentheses have perfect squares again. Remember, we said the sum of squares is prime. You can't factor it on down. Okay? What do you square to get x squared? X and x, plus and minus. What do you square to get 4? 2 and 2. Okay? One more problem. Okay, as I look at this, they're all even, so I'm going to factor a 2 out. Divide by 2, divide by 2, divide by 2, and divide by 2. Okay, now you have 4 terms and nothing in common. So you're going to group. Looking at the first 2, and I'm just going to draw an arrow because I'll bring my 2 down to the final answer. What goes into 2 and 3? Just 1. But I can see both of those have an x squared in common. So if I take out 2 x's, I'm left with a 2 and an x minus 3. Okay, 18 and 27 both have a 9 in common. And since the first term is negative, I want to pull out a negative 9. So divide by negative 9, divide by negative 9. Now you can see you have a binomial common factor. So we have 2x minus 3 and x squared minus 9. But if we look, we notice that x squared and 9 are both perfect squares. So we keep our 2x minus 3, and this becomes x and x, because that's what we square to get x squared, plus and minus, and to get 9, 3 and 3, and don't forget to bring that 2 at the top down to your final answer. And that's your lecture for 6.5.